Okay, hello everyone, and thank you for watching this video, which is sponsored by the National Science Foundation. This is the fourth interview in our series featuring experts in the field of digital manufacturing. I'm Jiangce Chen, a research engineer in the Department of Mechanical and Aerospace Engineering at New York University. And this is Susheem Kanwar, who is also a postdoctoral researcher at our same lab. Today, I'm thrilled to introduce Professor Chris McComb from the Department of Mechanical Engineering at Carnegie Mellon University, who is my advisor when I worked in CMU as postdoc. And I'm grateful that I had the privilege of working with such an excellent researcher at the intersection of AI and mechanical engineering. Uh, Professor McComb has a broad view in various aspects of mechanical system, from design to manufacturing. Particularly, he does not only care about the machines, but more importantly, the humans. Now, Professor McComb, could you please give us a brief introduction about yourself?
Yeah, well, thank you for the great intro, Jiangce. It was a privilege to work with you during your time at Carnegie Mellon. So I've been here at Carnegie Mellon for about 4 years. I run the Design Research Collective, which is my lab that focuses on various aspects of design, manufacturing, cognition. And then I also have the privilege of leading our Human plus AI Design Initiative. So that's an international and interdisciplinary group of faculty and researchers who are focused on how we bring together human and AI elements in the design process. Previous to this, I was at Penn State for several years, and before that, I actually got my PhD right here at CMU. So thank you for the chance to speak with you today.
Yeah, that's great. Okay, now can I talk about your story? How do you become interested in this field and end up where you are?
Yeah, so I've always been fascinated by manufacturing. It's sort of the physical foil to design in some sense, right? I think of design as how we bring concepts out of nothing, and then I think of manufacturing as how we bring physical objects out of nothing, right? So there's this natural connection. And I started off as more of a pure design researcher. I was really interested in how we can use AI and machine learning to support people in designing better artifacts, but mostly in a digital context. When I arrived at Penn State, I had the chance to start working with some folks like Nick Meisel and Tim Simpson, who started to expose me to advanced manufacturing, and they were some of the people who taught me about additive manufacturing. And exploring all of the potential interaction between the digital design methods that my group had been developing and the digital thread that's so core to additive manufacturing has been really fun to examine. So since then, we've started to look at some design algorithms for additive as well as some simulation and surrogate models for additive, which we had the pleasure of collaborating on, Jiangce.
Yeah, this is my pleasure as well. Uh, so can you please tell us about what's a typical day like in your line of work and how is the learning curve?
Yeah, that's a great question. So, I'm a professor, right? I'm a tenure track professor at an R1 university. So, a lot of my day is focused on research and advising and working with students. So, on a typical day, I'll have a stack of half-hour student meetings where we work together, troubleshoot, problem solve, brainstorm, and make sure that we're advancing their research in some way. I usually have some time during the day for proposal writing as well. And then a few days a week, I also have the privilege of teaching students here at CMU. The teaching I'm doing right now is closely related to mechanics and design. So it reinforces the manufacturing research that I do really well. Um, so yeah, A lot of digital work, a lot of some programming. I get to do a little bit of individual contributor work still, but it's a lot of managing and guiding research with the students and staff who I work with.
Yes, this sounds
Well,
very interesting. Like among all these things you do, can I ask what's the most thing you find you enjoy the most about?
yeah, no, and that's changed a little bit over the course of my career. So when I first started out as faculty, I really loved doing research, right? So I really loved getting in the details with my students and contributing technically to the work. Um, as I have progressed a little bit more, um, I've started to put my time elsewhere and enjoy different aspects. So I started to really enjoy doing proofs of concept and then handing those off to students to work on further. I really enjoy teaching, and I've sort of started to see teaching as the core component of this job. When, obviously when you're in the classroom, you're teaching. However, in research meetings with students, right, that's still teaching, right? I'm interacting with them and helping them learn how to be more effective researchers, helping them learn how to be better at the research. So it's all teaching. And honestly, that's what I enjoy. I enjoy working with folks and helping them develop their skill set, helping people grow and learn and change and become better than they are. Uh, Coming back for a second, the second part of your last question was about the learning curve.
Yes.
Um, and the learning curve in academia can be pretty steep, right? I think the two of you are postdocs, right? So you probably experience some of that learning curve as you finish your PhD and start a new position or as a research scientist, right? The job tends to change. So the learning curve is steep. You will encounter new learning curves throughout your career. So honestly, one of the things that is most important as an attribute for this career is having a growth mindset, being ready to learn new things, and being prepared to adapt and take on new challenges. So I think the learning curve is something really important that I don't want to glaze over. But that learning process is the complement to teaching, and they go really closely together.
Wow. Yeah, this sounds a very exciting job. And
It's a pretty good job.
yeah, so uh, Sushin, could you please do you want to ask some questions?
Of course. So uh, you seem to be wearing multiple hats, what with teaching as well as research and with the design collective initiative. Could you explain a bit more about some of the important contributions you have made in the fields of manufacturing and AI?
Absolutely. So in AI more generally, my group has pioneered some digital twin technologies for human design teams. So we've created simulations that allow us to predict the behaviors of human designers. More recently, over the last couple of years, we've started to take that into physical advanced manufacturing domains. And while we haven't made contributions there yet, I hope that we'll be able to map some of our previous results onto advanced manufacturing. More specifically, as it relates to the technology, one of my first PhD students in this area did some really interesting work that tried to tie the characteristics of engineering design data sets to the attributes that we might want to predict for additive manufacturing from training on those data sets. And by doing a large set of experiments across a variety of different synthetic data sets, he was able to identify how the attributes of the data relate to the trainability of the model. And lo and behold, one of the biggest factors is the size of your data. That accounts for about 80% of the trainability. But the last 20% comes down to the diversity of your data and the complexity as well. So that's one area that we've made some contributions. Over the last 3 years or so, especially working with Jiangce and Professor Sneha Nara here at CMU, we've done some really exciting work with surrogate modeling for thermal buildup and temperature in the wire arc additive manufacturing process specifically. So those are a few of the contributions that we've made more germane to manufacturing.
Wow. So it seems that the inputs or the data sets seem to be the secret sauce for success
They
in this
do.
field.
They do. I'd
Yes,
also like to just highlight the fact that my, these are not my contributions alone. I am blessed with a ton of amazing collaborators who've made all of this possible.
absolutely. Absolutely. And in addition to the diversity of the data set that you talked about and this quantity, of course, which is important as well, do you think there is a need for established standards in this field? And what role, if any, have you played in establishing those standards or setting those standards?
Yeah, that's a great question. So some of the work that I mentioned where we were looking at the attributes of data sets uh, showed us that you can learn better if there is less variability in the data, right? So you want to, or sorry, you learn worse if there's more, you learn worse if there's more consistency in the data, right? So variability is actually a good thing. So lack of standardization, we might say, is positive for machine learning. However, we need some degree of standard, right? Just to make sure that everything fits into our machine learning models. I have not played much of a role in this. I've contributed to some calls from NIST for input. Um, I think the biggest standards need right now is around AI. Um, and that's for two reasons. So first, I think that AI has become this umbrella term that's kind of useless. So having some standards development around just terminology and taxonomy and ontology would be really valuable. But second, I think that developing standards and developing some legislation around AI will introduce a degree of healthy friction into the system. Um, I'm a little concerned right now that we're automating the work of mid and junior engineers at the risk of never finding new senior engineers, right? And that scares me. I think we need a little friction in the AI development process just to allow the human system to catch up to these changes.
Right, absolutely. And that's a very interesting perspective about uh, if the jobs of the junior engineers get automated, how will we get new batch of senior engineers? So thank you for that perspective, Professor. How, other than that, how do you see the field in general shaping up in the future, and especially in the near term? So let's say the next 5 to 10 years. And how do you see technologies like AI, which are changing by the day and seeing advancements by the day, impacting that future?
Uh, so if you would have asked me this about 6 months ago, I would have had a much more definite answer. Today, I'm not sure. So what's changing, right? Global supply chains that have traditionally been strong are fracturing, right? So that's going to change it a lot. Training data that we might have been using previously is now out of distribution, right? So I see a shift in the coming years being that we rely a lot more on synthetic data than actual like sampled, measured, observed data. Just because the world is changing and we are a forcing function, right? So we're pushing ourselves out of distribution. So I see that being one big factor. A second contributing factor is, I think there is going to be a shift in where funding comes from, right? I think given some of the things we're seeing at the federal level, it may be likely, and another equilibrium point might be that academia starts working more closely with industry as a source of funding, right? Which would, in a really nice way, drive a lot of our work in IoT, AI, and Industry 4.0 in being more applicable, right? And getting some of that out the door.
Mhm.
So the next 5 to 10 years are going to be really uncertain, but I think a lot of things are going to change, and it's going to be a very exciting time to be working in this field.
Well, thank you so much, Professor.
Absolutely.
Um, I'd like to hand the interview over to my co-host Jiangce to finish it off.
Oh, yes. So the final question we have today is, what's the one piece of advice you would love to give young professionals entering this field?
So, I would say that as a young professional entering the field, entering a research career, um, you need to be three things. You need to be brave, you need to be curious, and you need to be empathic. So being empathic it's the starting place, right? Being empathic, being able to relate to other people is how you find collaborators, right? Using empathy is a way to learn more deeply about the problems that others care about and the way that they're trying to address those problems. In addition to that, we need curiosity, right? So as we get to know people, we need that curiosity to lean in a little bit more, right? And have that curiosity, that unquenchable interest to learn about what they're doing, right? Because we could become better collaborators when we learn about the other person's field as well. And then finally, I think we need to be brave. Um, so this bravery comes in asking the right research questions that are valuable for the right reasons, even when the answers might not be the ones that we hope for. So bravery, curiosity, and empathy.
Mm. Wow.
Fantastic.
Mm.
Thank you. Thank you, Professor, for that perspective and for sharing
Pleasure.
your candid opinion with us.
My
Okay.
pleasure.
Yeah.
Thank you so much for the conversation.
Yeah. Thank you for the insightful thoughts you give us today. Yeah. And thank you for your time.
Absolutely.
Yeah. Mm.